Welcome to Brain Vision.
In this problem, we want to calculate the angular momentum of the given particle about point P. We'll first need to calculate the position and velocity vectors. So the position vector are PA is equal to 2 minus 1 in the I direction plus minus 1.5 minus 1.5 in the J direction plus 2 minus 2k. And so the position vector r PA between A and P is equal to 3i minus 3j, and that's in the unit meters. Now we also want to calculate our PB. So our PB is equal to 3 minus 1 I plus 3 minus 1.5 j plus 0 minus 2 k. And so our PB simplifies to 4i plus 1.5 j minus 2k, also in meters. Now we have the position vectors. We need to find the velocity vector VA. Now the velocity of the particle is its speed, VA, times the direction of AB, which is the vector RAB over the magnitude of that vector RAB. And so this is the speed of the particle, 6 meters per second, multiplied by the vector RAB, which is 3 minus 2i plus 3 minus 1.5 j plus 0 minus 2k. And all of this is divided by the magnitude of this vector, which is the square root of 3 minus 2 all squared plus 3 minus 1.5 all squared plus 0 minus 2 all squared. And so we find the velocity vector VA becomes 6 over the square root of 25.25 I plus 27 over the square root of 25.25 j minus 12 over the square root of 25.25 k, and this is in meters per second. So now we have the position vectors as well as the velocity vector for the particle. To calculate the angular momentum of the particle about P, which is HP, this is the position vector R PA crossed with M VA. So the position crossed with the linear momentum of the particle, and we can also use the position R PB. Both will give us the same answer. So we can use the method of cofactors, and we can find this angular momentum. So we have I, J, and K components for each. And firstly, for RPA, this is 3 minus 3 and 0. And mva is the mass of the particle, 3 kg, times its velocity, which is 6 over the square root of 25.25 in the x direction. For j, that's 3 into 27 over the square root of 25.25, and in the k direction, that's 3 into minus 12 over the square root of 25.25. And so we find the angular momentum of this particle about point P to be 21.5 I plus 21.5 J plus 59.1 K, and this is measured in kg meter squared per second.